Let us see how we can perform aggregations within a partition or group using windowing or analytics functions. For simple aggregations where we have to get grouping key and aggregated results, we can use group by. If you want to get the raw data along with aggregated results, then using group by is not possible or overly complicated. Using aggregate functions with over clause not only simplifies the process of writing query, but when it comes to the performance, it is much better compared to using group by approach. Let us take an example of getting employee salary percentage when compared to department salary expense. Let's load the SQL magic and let's connect to the database. If you are running in the same session along with the other topics in this section, you might have connected to itversity retail database earlier. When you try to run queries by setting this environment variable to itversity HR database, it might say tables doesn't exist because the connection might be still with itversity retail. If you run into those issues, just go to the kernel and then say restart kernel and you should be good to go. Sometimes restarting kernel might not work. It might just hang after restarting the kernel. If that is the case, just make sure shut down the kernel, change the kernel to Python 3 and then you should be good to go. As of now, I have set the environment variable database underscore URL pointing to HR database and let me run this query. You can see the results. So this will give us employee ID, department ID and salary from employees. As of now, no aggregations are performed, only previewing the data with respect to the columns that are required to actually go through the details with respect to getting employee salary percentage when compared to department salary expense. So these are the three fields which we are interested in. That's why I'm previewing only these three fields. Now let us write the query using group by approach. First you have to get the department wise salary expense like this. Once you get the department wise salary expense, you have to join that with the employees table like this, and the join criteria will be department ID in this subquery and the department ID under employees. You can see the join condition here. So we are joining employees with aggregated department wide salary expense, and you should be able to see the results with respect to employee ID, department ID, salary, department wise salary expense and also average salary expense. Let us actually round these off to 2. For that I just have to say round, then circular brackets, then numeric like this, then 2, and you should be able to see only 2 decimals. Also let me say limit 10 so that we can only see 10 records rather than seeing everything. You can see the 10 records where we have the department wise salary expense as well as the average salary expense for each department. Now using this approach, you should be able to get the percentage of individual employee against the department wise salary expense like this. So let me copy paste this query and then we can say something like this. So salary of individual employee divided by department wise salary expense. In this case I want to multiply by 100 so that I get percentage like 10, 20, 30 etc. rather than saying 0.10, 0.20. And also I want to round these to 2 decimals and hence I can say round off comma 2 like this. This is percentage salary. You can see the details here. So with respect to department ID 10, there is only one employee. His salary is 4,400. That's why we are getting 100% here. With respect to department 20, there are 2 employees. One employee is making $6,000. Another employee is making $13,000. Total department wise salary expense is 19,000. You can see that here. As we are seeing the total department wide expense aside with salary, I am able to divide this with this, multiply by 100 to get this. So this is one of the approach where we can use group by to get the department wide salary expense and then join with the employees table and get the results as expected. Now this works, but it is a bit complicated and also from the performance perspective it is not great. There are better alternatives. That's where the analytic functions comes into picture. Let us see how we can get it using analytics or windowing functions. In this case, we can use all standard aggregate functions such as count, sum, min, max, average, etc. And this is how the query will look like. So I can say select employee ID, department ID, salary, and sum of salary over partition by department ID as department salary expense. You don't need to join with the table again. You can see all 107 records. Let's limit to 10 here. And you should be able to see the results. So we got the salary and department wide salary expense easily. Now if you want to get the percentage, it's pretty straightforward. You just have to say select employee ID, department ID, salary, and then department salary expense, and then you can say salary divided by sum of this one multiplied by 100, and I wanted to round it to 2 decimals, and hence I can say round off comma 2 as PCT. What is the field name I have given? I want to use the same field name here, so it is nothing but PCT salary. So I can say PCT salary like this, and you can see the results without any issues. So let's sort the data both by department ID as well as salary, so that both of us will get the same results every time we run. You can see the percentage of employee ID 202 when compared to department wide salary expense is 32% approximately, which is nothing but 6,000 divided by 19,000, which is nothing but department wide expense, and you can see the result. So it is as simple as this, and even from the performance perspective, this is much better than what we have seen earlier, because we don't need to join with employees table. As the data volume grows, this will outperform the other query at very bigger magnitude. Okay, so you should be very comfortable writing these type of queries for these kind of problem statements. Now you can not only use sum, you can also use the average, min, max, etc. For average, let's actually round it off to 2 decimals so that the output is a bit readable. We can say like this, and we should be able to run everything on top of salary, sum, average, min, max, etc. In this case, we have to typecast probably. Let me say numeric here, and let's see how it goes. Still it is not working. I know the problem. The problem is the round has to be on top of the complete this one, not just on top of average. That's why it was not working. Now I can say comma 2 and it should work. You can see the details as expected. You can see the sum, average, min, max, and also count. There is only one employee in this. With respect to 20, this is the sum, this is the average, this is min, which is nothing but 6,000, this is max, and this is the count. We have 2 employees. So this is how you should be able to use analytic functions to get the aggregations the way we are looking for. On top of aggregated results, we are also getting the raw data. Also, let me actually improvise on this query so that we both will get the same results whenever we run these queries. There is no comma here. Now it should work. Okay, now you can see the 10 records. Now let's see another example with daily product revenue from retail database. For that, I might have to restart the kernel because the connection is with HR database. Now, as I have restarted the kernel, I should be able to create this environment variable, and the connection will be with retail database. Now I should be able to run this query, and we can see the results here. It will just take a moment. Okay, as we have restarted the kernel, we also have to load the SQL magic. So let me load the SQL magic here. I have to say %load _ext SQL. Now it should work. Now you can see the results. So this is how you should be able to use aggregate functions with analytic functions and get the aggregated results along with the raw data. It is very important to ensure that you are very comfortable with these analytic functions so that you can actually solve complex problems with ease and also with efficiency. Using traditional approach or conventional approach of group by and then joining is not only inferior with respect to the performance, even the readability of the query will become quite complicated as the query size grows. So make sure you are really comfortable with the analytics functions and start using for those problem statements where you might have to have both the raw data as well as aggregated results.